Hey everyone, and welcome to the podcast for November 17th. I'm Avram Pelch, editor in chief of Tom's Hardware, and I'm joined as always by Associate Editor Les Pounder and Raspberry Pi expert Ash Puckett. And we have two very special guests this week as folks are piling in. We have Limor Fried, founder and CEO of Adafruit, the leading maker store and company around. Like, I think everybody watching this probably has a ton of Adafruit stuff and has used their site to learn. And then we also have Phillip Torrone, who's COO of Adafruit, here with us, and they're going to take your questions and, of course, talk about some new products. But first, let me just say what an honor it is to have both of you on the show. We are all just such huge fans of Adafruit and of you personally, Limor. I mean, your story of building this business, which I think you've had for 15 years now, is just really incredible. And everybody in the industry should be really grateful for like all of not only the products that you guys have put out, but the education that you've put out on your site, and like how you've really inspired, all of us adults, kids. When I first started doing, projects with my son on Arduino a few years ago, like all of our tutorials we were going through were from Adafruit. So thank you so much for everything that you bring to all of us. And I know you guys have also been doing some really important, like, I love to read your blog and some of this really important socially conscious stuff that you put on there. It's not just electronics, it's really empowerment, which is what I love about your company. So thank you. Are you guys, so I know I just want to start with a question. And I also want to point to our audience that if you have any questions for Limor or Phillip, please put them in the chat room. So before we get started, look at some of the new products that you've brought. I wanted to ask, how are things going with your PPE effort? Are you guys still making new PPE? I know you stopped production or deprioritized production on other stuff for a while there.
Yeah, back in April and March, we were asked by New York City Economic Development Council, or basically the group that ties business and government together, and they said, we can't get face shields for our doctors and nurses. At the time, like, you couldn't get them. Now you can, it's not hard, but at the time there was none. And they said, we're looking for companies in the New York area that can really quickly, like in a matter of days, make face shields for medical professionals. And we have laser cutters, we have kitting tables, we have elastic, we had all the materials. So we quickly respun our factory from making electronics into making face shields. And we made thousands and thousands of them for doctors and nurses. We also used 3D printers to make some. But basically, just like the thing is, they needed was speed, and that's what makers and hackers are good at. Is like, we don't have we don't need like a Gantt chart to get started. We just get started, right? It's just like, let's get what we got and get going. So now the city, they got like thousands of them. They were able to get through that initial rush of patients getting into hospitals and wanting to protect the medical workers. And then we were also helping the city in quick turn design of ventilators and ventilator assistant devices. At the time, we didn't know, did New York City need 10,000 ventilators? We didn't have them. We couldn't get them. There were like none anywhere on Earth. So again, working with Brooklyn engineers, MIT engineers, a bunch of engineers and makers and hackers got together. There's people who are makers and hackers during the day or during the night, but during the day they're medical engineers. So everyone had expertise. We had like people who were like really good at motor design, really good at UI design, really good at mechanical fabrication coming together. And I think about 1,000 or a couple thousand basic ventilators were manufactured here in New York City, and Adafruit provided the prototype parts, and we had like same day delivery and rush components because we actually had everything in stock already in downtown Manhattan. We could get it over to Brooklyn in about a half an hour.
Wow, that's amazing. So are you guys still manufacturing PPE of any kind?
Yeah, so we're still manufacturing based on what the retail world needs. So we still have face shields, we still source PPE, we have things like pulse oximeters, thermometers. Turns out this, as much as we'd all like to be done with this virus, it's all not done with us. So if you're in the USA, you can order stuff from us, adafruit.com/PPE. And one of the things that we found out was we have platforms, and we'll probably talk about that during PyCast, is we have things like the Feather ecosystem, which is an easy way, it's an open standard where everyone can kind of like Lego block different ideas together. And in our press section, you can see some of the things that we were able to find during the last 9 months, but there was a lot of fast track electronics that were from Adafruit that were used to fast track FDA approvals. So as gruesome as it sounds, there's times when you need to figure out, does this intubation thing work? And, they use like animal subjects like pigs, and, this pig thinks it's having a nice day. Pig goes into work, pig gets intubated, the pig survives. That's one of the trials for the FDA that they needed to see before it can pass to the next step. And then there's just things like temperature sensors. There's a lot of medical equipment that's needed. So we hear about our stuff used later. We always don't see it real time. Over the last few months, we were able to get back to shipping all things instantly. Before that, we were prioritizing anybody who was working on COVID related. So anything that's Bluetooth, anything that data logging, sensors, temperatures, even IoT stuff, we know it's being used a lot, and it's being used in very critical ways. We just don't know about it. So one of the things the city has asked us is like, please keep manufacturing, please keep making things. And then the other side of this coin is a lot of students are doing remote learning. So the teachers don't really have the same opportunities to do hands-on workshops, but they use things like Circuit Playground Express. That's one of our very easy to use, low-cost devices. And you can use block coding like MakeCode. Then you can use JavaScript or static Python, or then eventually something like CircuitPython and even Arduino, all of these things. And because our tutorials are online, learn.adafruit.com, teachers are now able to have curriculum and lesson plans and get low-cost, high-quality electronics to their students that are, a lot of them that are stuck remote. And even if you don't have a great computer, when we designed something like the Circuit Playground Express, we talked to New York City school teachers, and the students there were assigned like a Windows 7 laptop. And they're like, we don't even have internet access some of the time. We have a USB port, and we want something that's like $20. It teaches Python, has all these sensors, and has a microphone, has all this stuff. And they went through this long list of things, and it was not possible at the time. This was years ago, but then eventually technology catches up, and we were able to do something like Circuit Playground Express. And then there's a lot of machine learning curriculums and a lot of AI curriculums, and that actually brings us to Braincraft, which we're going to definitely talk about today, which is a way to teach machine learning in the easiest possible way, and that's been helpful. So we hear from government organizations, please make all your electronics. We use it for important mission critical, sometimes medical needs. And then from educators, please keep making electronics, especially now. People are like, yay, USA, manufacturing USA, to get to our students because they're stuck at home. We need to do some type of learning besides just like, here's a screen and we're going to just do Zooms forever. We actually need to do some type of curriculum that teaches skills. So long answer to your question. Yeah, we're still making everything.
Great. Fantastic. So speaking of some of the things that you make, and it's just really impressive how, I mean, maybe not a lot of people, maybe not everybody knows that Adafruit makes like a number of its own platforms. So besides Circuit Platform and Feather, I mean, you guys have, how did you decide that you were going to make some of your own boards like that, in addition to obviously providing great support for Raspberry Pi and Arduino and other platforms?
Yeah, well, we've actually been making our own kits before Arduino existed. We started making kits 15 years ago. I think Arduino is like 14 or 13 years now. We made little microcontroller boards because microcontrollers are very neat, and they finally became easy enough that people could use. So we had, kits and synthesizers and Minty Boost, and some of these kits we still sell, like the TV Gone kit is still sold at Adafruit, and the Minty Boost kit. And then, at the time, 15 years ago, when you were making electronics, hobbyists would there was a smaller number of hobbyists, but they were comfortable with soldering together the projects. That was actually kind of how most electronic like DIY projects were done, is you would get all the components and you'd put them on the PCB. The only custom part was the PCB. But, over the last, decade plus, the components have basically, the through-hole ones have been discontinued for the most part. And all new interesting components and new chips are only coming in surface mount. And so that's where you saw projects like Arduino, right? Arduino, even the first one, required a surface mount component. It had to be manufactured and come to you pre-assembled. It was too difficult for people to hand solder. And then, that kind of built onto, more and more platforms and more advanced products. Before the Raspberry Pi, there was, Bunny's Chumby board, and then there was like the BeagleBone. So there's been, and even before that, there's like, PC 401s or whatever they were called, or PC 104s and Gumsticks boards. So there's actually been, all the pieces have been there. It's just suddenly gotten easy and inexpensive enough for people to use. And, we don't like to recreate something if it already exists. Like the Arduino does an excellent job for what it is. There's no point in us making something exactly like the Arduino when we can just use a popular platform and build on top of it. But there are some situations where we're like, we want something that's very specific, and we have needs that aren't met by, the existing market. So for example, like we just released this, all-in-one e-ink Wi-Fi board, and this one is going on to the internet and getting shower thoughts from Reddit and displaying them. Sometimes witty, sometimes not that witty. And one of the goals we had with this was making it battery powered and making it use this new Wi-Fi chip, the ESP32S2, and using e-ink and getting it low power. And for that, we have to design our own products because we have to tightly control all the components and everything. So we make add-ons for existing boards such as Raspberry Pi and Arduino, and BeagleBone and other platforms. But the goal we have is try to unify that experience as much as possible. So what we want to do is make it so when you program one of these platforms, the programming you're doing is the same from platform to platform, just the power and the capabilities change. And that's kind of true of computers. Like if you buy a Mac and it's like you had one of those old blue iMacs, you want to be programming it in the same way that you program a modern MacBook. You don't, and you can see Apple's doing that as well. They're kind of unifying macOS and iOS, trying to make it so that it's the same experience for programming and development, but on different power and different capability platforms. We're trying to bring that flexibility to microcontrollers and hardware programming. And, hardware programming is 10, 20 years behind desktop software programming. So it's kind of fun. We're having the same exact problems, but we're just trying to solve them with less RAM.
Very cool. So speaking of new products, let's talk about that e-ink display. It looks really cool. I know, Philip, you had something special that you built.
Yeah. I'll switch over to my other camera. And this isn't the data that it's displaying. I don't like the data, but I think it's a good relevant example that's in all of our lives right now. So this is a laser cut COVID shape. And what you're seeing is the live data feed from COVID project or covidtracking.com. Limor can correct me if I'm wrong with that. And
yes.
Because this uses Python's really good at IoT stuff. This is really hard to do in just about every other programming language, especially for microcontrollers. So this goes out, gets a JSON feed, and it will tell you how many new positives there are, current hospitalization, change in hospitals, total deaths, new deaths, and then there's a little QR code there that you can use your phone to go to the website. And this is a refrigerator magnet, so you can see what it is every day. We have this set up for the New York City data as well. We're managing 100 plus people. Luckily, we've been safe and we've had PPE and we've been able to do really strict protocols. If anyone's interested, if you run a company, go to adafruit.com/opensafely. We publish exactly how we do everything down to we do a monthly surface test on all of our surfaces to see if there's any viral load. And more information is better. And so this particular project just shows all the types of information you see ticking down the side of the screen on newscasts. It's also a good example of this is relevant information for someone right now. It wakes up, it'll go get the data, then it turns itself off, and it's e-inked. So when it's off, it still displays this, and it's not drawing any power. And this is a really good example of what Limor was saying is there's really powerful microcontrollers out now. And this is times where you can make a platform, you can build on top of a platform. And we've also unified on how we do things. So if you're into Python, you can run a lot of this same code on Raspberry Pi. You can run it on this microcontroller. You can run it on your desktop computer. And depending on where you're at in the world, Python is taught as the national programming language. France, for instance, and a lot of schools do that as well. And depending on what data source you want to display, this is a very easy, fast way. Sometimes we hear like, oh, it's like cheating because it's so easy. Because this used to be such a hard thing, doing fonts on an e-ink display, terrible, hard. Being able to do the spacing, the kerning, the graphics, being able to generate a QR code. And kids are able to do this. Of course, modern kids are way more advanced than all of us when we were kids. But this is a good example of being able to take something that used to be very hard and then making it something very useful, as morbid as this is. I can say when we were looking at this with our other devices and projects, we have something called the Pi Portal. Over the summer, it was great because over the summer, the numbers were going down and down and down and down. And we were all like, okay, this is happening. Now, unfortunately, they're going back up. So now you have to be smart. And this is just yet another thing, another ambient-like device that you can have in your household. You can build it. It can also be a good teaching tool. And for under $40, it does all of this and more. So that's the MagTag.
Yeah, we have somebody who in the chat room saying do gardening stats like soil, moisture, and irrigation. Yeah. I'm sure that would be pretty easy to do. You probably just have to connect it to something that had a soil sensor.
Yeah, we have a whole slew of things. In fact, we have stuff from microbit all the way to our microbit shaped device. It's called Buckaroo Bonsai, and it's a really neat soil monitor that allows you to do soil sensing and more. We also did a partnership with 4-H where we made a Circuit Playground Express that's green. Limor, why don't you talk about how the gardening stuff works? Because we have a lot of people who do home gardening now.
Yeah, it's funny. There's a lot of people who use our hardware to do both gardening and like aquarium projects. People who have like really advanced aquariums, which is basically like water gardening, right? And what's neat is you can get sensors for all this stuff like pH or moisture, and then plug them in, and we have the chips themselves that do the sensing. We have drivers for them for Arduino or Python or CircuitPython, and so people use a Raspberry Pi, or they'll use a microbit, or they'll use an Arduino and take that data, and then they can upload it to one of our I/O services like Adafruit I/O, or there's other ones like ThingSpeak or PatchBay or whatever, and then have automated events occur when, say, the moisture, it gets too low. It'll send you an SMS message, or it'll automatically turn on the water. So that's a very common thing. It's like gardening robots are really popular. We even interviewed Helen Grainer, who just she's one of the co-founders of iRobot, and she's working at Turtle now, which is more gardening bots. So gardening bots are cool right now. Oh, you're muted, Avram.
Sorry.
Hi.
So I was thinking just a few weeks ago, we were talking with Pim Maroney, and they've just come out with some gardening kits as well.
Yes, so. People love to stick stuff in their plants. They got plants at home. You might take care of them and sense them, because it's kind of fun. It's interesting, right? You want to see what's going on with the plants or the garden that you have in your house. A lot of people, it's something that they care about every day. But anything that can help you get rid of the drudgery part and get more to the fun planting part, caring part.
Yeah, I can also see folks would definitely use that e-ink board for things like a scheduler, because that was something that we covered on our site a while ago, which is actually putting up some kind of a red light outside your home office to say, like, don't bother me. Not that my children would actually listen to that.
No, they wouldn't listen. You have to add like an electrocution fence.
Yes.
We have a bunch of projects. People made projects using like Google Calendar, or just a remote button, something that's Bluetooth, and then outside their door, we have a couple projects that use our latest matrix portal, which is a RGB matrix sign that you can program with Python. And yeah, it's a very common project that people have now built. Again, it doesn't really stop anybody, but worth a shot.
If you could go to my screen share for a second, this is the Adafruit Bonsai Buckaroo. It's microbit and Clue compatible, and this is kind of what the person was asking about. So you can use either a microbit or a Clue, and you can water a plant, do all sorts of moisture detection, and with the upcoming Wi-Fi everything, you can send this off to a data source. We have Adafruit IO, which is our free IoT service for makers. The question I'll ask myself is, why did you make an IoT service? Because all the IoT services out there, they kept going out of business. So we wanted to make something for makers that would allow them to know what their data is being used for. So we have an IoT Bill of Rights for this. They can use it to privately log things like plants, or they can make public feeds. We really wanted to make something that really worked well with all of our hardware, but you can use anybody's hardware. And because we're not an IoT data company, you don't have to worry about it going out of business. It's supported by Adafruit, and it's not a standalone business in itself. So that's something that we're pretty proud of, because there really wasn't any good options out there. So we have people that they were using it so much that we eventually started to make Plus accounts. We had someone who's like, hey, I run an entire shrimp farm, and they have all sorts of water and temperature sensors across this big farm of shrimp. And we said, okay, we'll make a Plus account. So for a Plus account, for $9 a month, you can do more feeds and stuff like that. And anyways, this is just one of the many projects. We're seeing this a lot because people are spending more time in their homes. And they're like, I'm going to finally, take care of a plant. And now I'm going to definitely water it, and because I'm home more. But then they're just like, I forgot to water it, so I need a little device to tell me. And then some of the things that we see, especially in the maker world, is people will attach sensors so they can figure out the amount of electricity that can go through or that's going through the plant, and they can have it do things like become a musical instrument or trigger a sound. If it needs water, it'll say something like, water me, which is kind of neat. A lot of our boards, you can put a WAV file or an MP3 file. And I think, let me see if I can go to our learning system. Here's a PyPortal pet planter with Adafruit IO. So as you water the plant itself, our little screen will show that you put water in it. And this uses Adafruit IO, so you'll be able to do things like show what's going on for that particular plant. So there's no excuse to kill plants now. You can keep it alive.
None at all. So speaking of things that really cool new stuff that you guys have, I want to make sure we get to talk about the Braincraft, which is this new AI friendly hat. So what can you tell us about the Braincraft?
Yeah. So I think machine learning is kind of the hot new thing. Folks want to play around with, TensorFlow and Keras and other machine learning, but basically making it easy enough that people can actually do it on their own without having to have a degree or take classes in machine learning. And what's nifty is that, for a few years, it was like, okay, you can run TensorFlow on a computer if you have a video card. And then eventually it was like, okay, you can run some basic stuff on a computer or mobile phone, recognizing objects or doing voice recognition, using, an internet backend in the audio recognition case. But you can do video recognition on the device itself. And then when the Raspberry Pi 4 came out, the Pi 4 is actually a good enough processor that even though it doesn't have a machine learning coprocessor, doesn't have that graphics card or what's called an edge TPU, a little thing that you add on to help accelerate it, it can do some basic vision recognitions using the Raspberry Pi camera. And why this is neat is because when you do recognition on a computer and you're you hold up a coffee mug and your computer's like, it is a coffee mug. It's like, okay, so who cares? So what? But when you have a Raspberry Pi, it can recognize things. It can turn on lights or move a motor. Really common project is people want to recognize when their cat or their dog is in front of the feeder, and then the feeder, adds food into the bowl, or, it opens up the cat door, so let the cat in, but not let a raccoon in, for example. Like that's a very common project that people want to experiment with. And like all this capability is actually like available and free, and it's not even that hard to get set up. So about a year ago, we actually had some of the lead developers from Google come by our web show, and we asked them like, okay, the Raspberry Pi 4 is finally the first low cost, $35 computer that can run TensorFlow Lite, not like TensorFlow Lite for micro, but like true TensorFlow Lite. What would you want in an add-on to expand that capability and make it really usable? You can watch the video. It's from like September of a year ago. We had no idea back then. The future was totally different. We had different plans. And, they were like, well, we want a little screen so you can see what the camera is seeing, because this is a common problem. People make visual recognition projects but don't realize like the camera isn't pointing at the item right, or like there's just no way of getting feedback. So they're like, okay, we want a little display. And then they're like, well, we also want it to be able to do audio projects, so like have a microphone and headphone capability built in. The fan is on the back because Raspberry Pi 4 actually gets a little bit hot, and if it doesn't stop working, but it starts slowing down. So we have a little fan on the back that spins up when it gets hot, and it cools off the Pi 4, keeping it from getting too toasty. And then we have some RGB LEDs, and we have like a joystick and button. We also have this really nifty thing on the top left. There's a switch. And the switch lets you completely turn off the audio subsystem for the microphone. And this is really important because part of our IoT Bill of Rights is that if you have a device that can listen, there needs to be a hardware switch that you can turn off to make sure it's not listening. And not like a software like click to enable, disable, because that gets confusing, and you don't, maybe we boot it, automatically turns back on. This is a hardware switch. When that switch is off, there is no way for audio to get recorded on the Raspberry Pi. Like it's literally like there's no way for that to work. And you can be assured that if you're working on projects and you don't want it to listen in, you can turn it off. There's no risk of it ever listening into you. Now the camera, you cover up the camera, that's a little bit easier, but it's often tougher to know like if something's listening or not. So that's kind of neat. So we've been adding that to all of our machine learning boards, the switches that have audio recognition. There's always a mechanical switch to turn it off. And then there's also coming from Google, they're coming out with lower cost TPUs, these add-ons that add acceleration capability. And so we're going to add some of that capability as well going forward. But a lot of people have like a Raspberry Pi 4. They're going to have the Pi 400. It's going to be very common for people to have these in schools, have these low cost computers that can do recognition and then maybe do something with it. And I think that will make machine learning more interesting. I think that the way to teach some of these advanced concepts, because people can train their own models and then they want it to do something when something's recognized. For example, is somebody wearing a mask or not? You want it to have a little sign that lights up and says, please wear a mask, right? Or another common project is counting the number of people in a room, because you want to make sure that you keep your occupancy below a rated amount. That's something you can do with a Raspberry Pi as well, and it can like have an alarm or something. And you don't need a full computer. You can do it with like this $35 off-the-shelf thing, which is pretty neat.
Yeah, that's amazing. So would you recommend that folks get one of those Google Coral Edge TPU add-ons to use with this, or do you think it works fine?
You don't need it. I think actually, look, I mean, if I worked for Google, I'd be like, buy it. And there's nothing wrong with buying it. But I actually think that for a lot of people, you want to get people started at the most basic level, because it's not just about money. I mean, some people, they just don't have the money to afford it. They don't want to spend that money on hardware they don't need. But there's also the cheaper something is, the less fear people have to experiment. If it's only a $35 computer, they're not as worried. Like installing Bazel and TensorFlow on a computer is like actually kind of traumatic, right? Before you know it, you have like 15 versions of Python installed, and you don't want to mess up your computer. Or if you're a kid, you don't want to mess up your parents' computer. But if you have just a Pi 4 and like an SD card, this is all under like $50, $60. The risk is very low. Even if you like totally screw up and mess up your install, you're only an hour away from starting over from scratch. So I would actually say all you really need is the Pi 4, an SD card. You probably already have one. Power supply. You do need a good power supply, but you probably have a USB-C, phone charger somewhere in the house. And then the Braincraft hat, which will let you like do all these projects. And then just get the simplest Raspberry Pi camera. and you can do pretty much all the projects.
Yeah, that's awesome. I mean, it's just so. Les, you've actually been using it for a few days. How are you finding it?
Really good, thank you very much. It's, as you can just see, hello, here. It's really good, really simple to use. The guide is fantastic, which we've come to expect for Adafruit guides. I've used quite a few of those, and it just works. I mean, I've got a very quick demo now to show you. As you can see, here is my desk. Excuse the mess, and I've got an apple in front of the piece of kit now. And if I just zoom into the screen here, you should be able to read just about. It's saying Granny Smith, so it's very specific on the type of apple.
That's really specific. That's exactly right.
Which
Yeah, it knows dog breeds as well, as we learn. We don't own a dog, but our friends in Florida, they own a dog, and they pointed and it was like, "This is your breed," and they're like, "Wow, This is amazing." This is the MobileNet, machine learning vision package that we're using, and it's very common, and it recognizes a couple thousand different objects. It's really good with things that most nerds will have, because the people who programmed it, I think they took a lot of photos of things around their desk as well. But it can work about 4 to 5 frames per second. But yeah, if you add an Edge TPU and install the TensorFlow Lite with Edge TPU support, you can get like 100 plus frames per second, faster than the Raspberry Pi camera can actually get you the data.
Wow.
That's really neat. So once you buy this, you can just get all the instructions tutorial from adafruit.com, right?
Yeah, and that's the hardest part, to be honest. Actually, making the hardware was not as hard as figuring out the easiest path for people to reliably be able to install TensorFlow Lite and get the software going. We did, based off a bunch of guides that we found on the internet, we kind of cobbled them together and found a good path. But we did get there eventually. And so, as long as TensorFlow Lite, when it revises, we'll update the instructions again. But so far, so good. And we've got 2 projects you can do. Actually, we have a couple projects. We have the TensorFlow Lite vision recognition using the MobileNet model, which is the default you just saw. Recognizes a couple thousand different items in common situations, like on your desk or in space. We also have one that can recognize objects and like put a box around them. It doesn't recognize like individual dog breeds, but it can recognize like a dog or a cat or fruit or a computer, and it can put boxes around it. That's a different kind of model, and it's a little bit more computationally heavy, but you can still do about 2 frames per second on a Raspberry Pi 4. And then we have the vision recognition, which is you can set it up to be like a Google Assistant. You have to make a Google account and tie it to your Google account using this OAuth little step. But then you can ask your Raspberry Pi, like, "Hey Google, what's the capital of Alaska?" And it'll act as if it was a Google Assistant, which is kind of neat. And there's also using the online. It's called Teachable Machine. It's an online way of training new vision models from Google. You can point it at different items and then create your own model, right? Your own recognition set. So we show how to point it at like a capacitor and a resistor or a transistor and a chip. Like these are items that are not in the MobileNet model. Like it wouldn't know what those items are, but you could train a new model and differentiate between these items. Like instead of just a playing card, it would know which playing card because you would train it on all 52 playing cards. And then you can deploy that model onto your Pi and it would recognize it just like it would that Granny Smith apple, but it would know the individual items that you've trained it. And Teachable Machine is really nifty because it's kind of all in one. You just use your computer video camera and you point at the thing and you basically just move it around and you twist it and you get all these little different frames of how it looks in different lighting. And then you can test it right there in your browser and then deploy the TensorFlow Lite model. So that's the hard part. That's the part that's usually been very challenging for people to do, how to train a new model. But thankfully, that part is being designed. People are designing websites and assistant tools to help people with that step.
That is really amazing. Now you've given me some ideas for my son and I to work on, because we were talking about how are we going to train a new object model to do things with. He wants us to build a robot that does different things based on what you show it. So
So if people train up different like Lego characters or toys, it can recognize the different toys, but you do have to train it. That's the thing. It doesn't automatically know what these things are. So you have to like put the fire truck in front, and then you rotate the fire truck and you take a lot of different photos of it. But then next time you put the fire truck or like the police car or the train in front of it, it'll recognize those toys. So do check out Teachable Machine. We have a guide on how to use it and test it and then deploy it to a Raspberry Pi.
That is awesome. I know we've kept you guys a long time. I just had one question from our audience, since we had quite a few people. We've had a few people in there. Someone asks, what did you use for a tripod attachment?
Oh, for the Raspberry Pi camera, we have like a really low cost case that has a standard like quarter 20 threaded insert. I can go to the Adafruit shop and show you.
What do you want me to search for? Because I have the screen up here.
It was the camera enclosure. It's 3253.
Okay, 3253.
Yeah.
There you go.
So for that case, on the back of it, if you look at the second to last photo, there's a threaded quarter 20 insert, and so you can just, like you see here, I just got one of those like gorilla potty type things, and I screwed it into the back, and then you can just twist it around and position it how you like. I think you could also use a standard like USB webcam. I haven't used those with the Raspberry Pi because I have the Pi camera and they're great quality, but this case is only a couple bucks and it just sort of solves that problem for you. There's also straps you can like attach it to something.
Yeah.
This solves a really significant problem because that's one thing that the Pi camera, you always have to find a way to mount it.
Yeah.
So this is great. Well, I want to thank Limor and Phillip for coming on from Adafruit. It's been such a privilege to have you guys. Thanks so much from all of us. We're not worthy, but thank you for coming.
Can I do one last pitch?
Oh, sure.
Okay, cool. So if you want to pick up a Braincraft, as you saw, they're in stock, and we now have a special deal. We have 20% off like almost everything in the shop if you make an account and you secure it with two-factor. And this is a great way to get like a one-time 20% off coupon off, again, just about everything in the store, not gift certificates, not Raspberry Pi computers, and not subscriptions, but like everything else, including the Braincraft hat. And we want to get people to use second-factor authentication on their accounts. Everyone, you're stuck indoors. It's a good time to secure your accounts, change your passwords, and maybe learn some electronics. So we're going to make it really easy for you.
That's great. I'm going to be going to
Adafruit
and using that today.
How can you not see it? It's 20% off. It's free money. So yeah, thank you for popping that up. But we have detailed instructions on how to do it. Again, all you have to do is create an account and use two-factor authentication. And then after you're done, maybe do that for your other accounts, right? It's a good idea to set up two-factor.
Yeah, you'll be inspired. Well, thank you guys so much. As always, you can catch us at 2:30 p.m. Eastern on Tuesdays, or 7:30 p.m. British time, since a lot of people dial in from the UK. And thank you so much, guys. We hope to see you again soon. Bye, everyone.
Thanks, guys.
Thank you.